Great, it's recording now. Let's talk about section 3.5. It's called long division. Welcome, Savannah. How are you doing today? Everything good? Okay, let's start. Let's start by recalling how we divide whole numbers. Okay, and then we will extend it to division of polynomials. Okay, we will mimic what we do here. I will explain to you. So first, let's recall how we divide just whole numbers. When, for example, when they ask you to divide 5 into 67, what do? Well, we separate enough digits, right? So that we can divide this number by 5. You separate one digit here and you go like this. How many 5 into 6? Well, that is just 1, right? You have 1 here. 1 times 5 is 5. Subtract. This subtraction gives me 1. Next, you bring down the next digit, right? The next digit will happens to be a 7, right? 7 there. And then you start this process again. How many 5 into 17? Well, that is approximately 3, right? 3 times 5, 15. Subtract again. This is 2. And then we don't have more digits to bring down, which means that this is it, right? This is it. This is the end, right? Now, once you are done, this guy is called the remainder, right? This guy is called the divisor, right? This guy that you get out of this algorithm is called the quotient, right? And it's considered to be the answer, right? Quotient of this together with the remainder, if there's remainder, right? And this guy, the 67, is called the dividend, right? Dividend. And all this together, all this process all together is called long division, right? Long division, so long division. And this is what we're gonna do next, but with polynomials, we'll show you. Now, in order to write the answer of all this work, two ways to do that, answer. First way is this, quotient 13, followed by a remainder of 2, right? 2. So quotient are 2 for the remainder. Now, in case you don't have the remainder, you don't have to write this part, right? You just write the quotient. Now, equivalently, and this is something that you're going to use in calculus too, this other form, there is another way to write this, right? It is the quotient 13 followed by a proper fraction made of this. On the numerator, you put the remainder, and on the denominator, you put the divisor, right? Remember? It's like a mixed number. So 2 ways to present the answer. Okay, but now let's try to mimic this and do it with polynomials, right? With polynomials. I will show you how. So if you try to do this with polynomials first, just like you chose here just one digit to start, you choose the first term of this polynomial, which is going to be the one that is part of the dividend, right? They're asking you to divide 2x squared plus x minus 5 by 2x minus 3. So this guy is going to be the divisor. This guy is going to be the dividend, right? Dividend, the first polynomial that appears from left to right, always inside the division symbol. Divisor outside, okay? Now, you start, as we did before, by taking the first term, 2x squared, right? 2x squared. And now you're going to divide that by the first term of the divisor. And I'm going to write this for you here. 2x squared must be divided by 2x, right? Or 2x into 2x squared. But what is that? 2 into 2, 1, x into x squared, just x, right? Just x. That x has a place here. Where? On top of the x term, right? On top of the linear term, x term. So you write it here. Then you're going to multiply just like we did before with numbers, right? This guy times the divisor, right? So x times this whole thing. Okay, so now mark this so you can remember that. So x times 2x minus 3. So you go like this, x times 2x minus 3. Let's get it done. X times 2x, 2x is squared. X times negative 3 minus 3x, right? And that must be written below these two terms, right? Look, 2x squared minus 3x. There is an order there for the term, right? Linear term with linear term, quadratic term with quadratic term, right? And now, just as we did with numbers, we are supposed to subtract this from this binomial, right? So it's going to be a subtraction of binomials there. Now, to subtract, guys, since we're working with polynomials, what I do is this. I distribute this negative sign over so that I get negative 2x squared here, right? And negative times negative, positive 3x, right? Positive 3x. I forget about this, I just add these two. Look, 2x squared minus 2x squared, 0, right? Nothing. But here, 1x plus 3x, that's going to be 4x, right? 4x here. That's it. Next, just like we did with numbers, remember we brought down the next digit. Here, bring down the next term, right? Which is going to be this constant term here. 5, right? This is a minus 5 coming down. And then repeat the process again. Take the first term of this guy. Are you going to divide it by the first term of the divisor, right? Let's do it carefully here. We are just mimicking what we do with numbers, right? This is the whole idea. So 4x divided by 2x. What is that? 2 into 4 is 2. X into x cancels, right? Just 2. But that number 2 has a place here. You have to put it on top of the constant term, right? On top of the constant term. So 2 positive, right? Plus 2. Very good. Now, this plus 2 must be multiplied by the divisor, by 2x minus 3, right? So let's do that here. 2 times 2x minus 3. What is that? Well, 2 times 2x, 4x. 2 times 3, 6, but negative, right? Negative 6. And this guy should be written below this binomial, right? In order, look here, 4x minus 6, right? And just like we did with numbers, we're supposed to subtract now this guy from this binomial, right? And get our difference here. Now, to help myself with this subtraction, I do this. I distribute the negative sign. Look, this will be minus 4x, right? And minus plus 6, right? So that I forget about this. I just deal with these two guys. 4x minus 4x, 0. Minus 5 plus 6 is 1, right? 1. So 1 here. Now I don't have more terms to bring down. This means that I'm done. This is over, right? This is over. So now let's just notice that this guy is going to be the remainder, right? Like before. This guy is going to be the quotient, right? So how do you present your answer here? Your answer, the summary of your work. Look, answer will be quotient x plus 2, right? R, remainder, right? 1, right? This is one way to present the answer. However, guys, you are headed to take calculus 1, calculus 2, right? In calculus 2, they will prefer this other presentation, the one that I talk about here, right? Remember, it look like a mixed number. Something similar. Look, you write the quotient x plus 2 first, and then this is going to be followed by a proper fraction. What proper fraction? The one having on the numerator the remainder 1, and on the denominator you write the divisor 2x minus 3. And this is a plus because it's a sum, right? Remember, this mixed number is 13 plus 2/3, right? So here you put plus. So quotient plus remainder over divisor. And this is a very, very common way to present the answer you will see on the multiple choice. Okay? All right, so that was how you divide two polynomials, right? Maybe before I ask you to do something on your own on the worksheets, I should show you another example here. Look, example 2. Okay. And point out some patterns, right, of this long division. Let's do this now. Divide 15x squared minus 11x minus 14 by 3x plus 2. Remember, when you go from left to right, the polynomial that appears first goes inside the division symbol, which is this, right? This other polynomial outside. It all starts by taking the first term of the dividend and dividing it by the first term of the divisor, right? So you're gonna do 15x squared over 3x. 3 into 15 is 5. X into x squared is x. This 5x must be written here, but it has a place. You're gonna put it on top of the x term. Look, minus 11x, so right there, 5x. Next, you're gonna multiply this times the whole divisor, right? Not just 3x, but the whole divisor, this whole thing, okay? 5x times 3x plus 2. Let's see what we get. 15x squared, 5x times 2, 10x, right? 10x. Great. Right? And this binomial must be written here below in order. And here, notice something, right? These guys are always the same, the first terms, right? So this is something that you need to catch. Always they will be the same. They will be the same. So that when you subtract this binomial from this binomial, this first column will always be 0, right? Will always be 0. Remember, in order to keep everything in order, I help myself by distributing the sign. I write minus 15x squared, right? And minus times plus minus 10x. I forget about this, I deal with this too. 15x squared minus 15x squared is 0. So it's not a surprise, right? It will be always 0 there. Now, the other term, notice minus 11x minus 10x minus 21x, right? Minus 21x. This is the difference. Next, we bring down the next term, which is this constant term, right? Minus 14. And then we start all over again. Take the first term here, divided by the first term of the divisor, right? So let's do it here. So you gotta do 21x negative, don't forget about sign, over 3x. What's this? 3 into negative 21 is negative 7. X into x cancels, right? So negative 7. That negative 7, guys, has a place. Goes on top of this constant term right there, minus 7, right? Then minus 7 must be multiplied by the whole divisor, right? So minus 7 times 3x plus 2. What's this? Minus 21x, negative 7 times 2, minus 14. This binomial, you write it here. Aha, this time, I got exactly the same binomial, right? Look, exactly the same. So not hard to see that this will be 0 and also this will be 0, right? Because once you distribute the negative sign, look, this becomes plus 21x, minus 1 minus plus 14, 0, 0. So nothing left, right? 0. So in that case, if the division gives you remainder 0, it means that your division was exact, right? So for answer, you just have to write the quotient, no remainder, right? Division was exact. So answer just 5x minus 7. That's it, right? That's it. Very good, guys. So 2 scenarios here. Sometimes you will get a remainder like in here, but sometimes you will not. So you just have to write the quotient. Now, I want you to practice, guys. Practice here. I'm gonna give you something to work on. Number 3 is good. This one. Can you try this on your own? I will start it out so you can have like a little hint there. Yeah, so this is telling you to do this division, right? 8x squared plus 24x minus 63. Remember, the first polynomial that appears from left to right is the dividend, this guy. And this must be divided by this divisor, 2x plus 9, right? So go ahead and try this out. Hint again, start by dividing this guy by this guy, right? It all starts there. So start there. So square over twice x. Yeah, start there. And remember, if your division doesn't have remainder, which apparently is the case here because I don't see any remainders there, right? It means that you just have to post the quotient, right? The quotient. Great. I see students are figuring this out. Very good, guys. So, yeah, very good, Jack. Very good. Yeah, you made my day. Yeah, it's like an algorithm, right? Long and tedious sometimes, but it's just that. If you follow all the steps, you should be fine. You should get your quotient or your quotient and your remainder, right? It's just an algorithm, right? Step-by-step algorithm. All right, great. So let's work this out together, okay? More students posting answers. Let me check. Very good, Khan. Yeah, you got it. Excellent. Very good. Yeah, it's not that difficult, right? Yeah, so start by taking the first term of the dividend divided by the first term of the divisor, this, right? What is this? Well, this is 2 into 8 is 4. X into x squared x. 4x. But this 4x has a place here, right? 4x on top of the x term, which is 22x, right? There. Now, next, you got to multiply this times this whole thing, right? This whole divisor. 4x is right here. 4x times 2x plus 9. But what is this? This times this is 8x squared. 4x times 9, 36x, right? 36x. And this must be written below this binomial, right? In order. Look, 8x squared plus 36x. Professor, we got the same here. You always should get the same here, right? It's a sign that so far so good. Yeah, great, right? And then we got to subtract. Remember, I explained to you that this subtraction will be always 0. The first column will lead to 0, right? Minus 8x squared minus 36x, right? Subtracting then, you get to see that this is going to be 14 negative, right? Negative 14x. If you have difficulties of doing this subtraction in your mind, use your calculator, right? Okay. All right, next we bring down the next term, which is minus 63, and repeat, right? Repeat this process. So minus 14 now divided by the first term of the dividend 2x. So minus 14x divided by twice x, right? What is this? Well, this guy is just 2 into minus 14 minus 7, right? That's it, right? Minus 7. That minus 7 has a place here, Where is that? Here on top of the constant term, right? Minus 7. So let's write it in blue. Minus 7 here, right? Great. And next, you have to multiply this minus 7 times the whole divisor. Minus 7 times 2x plus 9. But what is that? Minus 14x minus 7 times 9 minus 63, right? Professor, I got the same. Good, right? If we got the same, not hard to see that when you subtract these two, right? I help myself by distributing the sign over. This is plus 14x, this will be 0, and this is plus 63. 0, right? Nothing left. Means the division was exact. The answer should be just the quotient, right? 4x minus 7. That's it, right? Excellent, guys. So this is it. Excellent. Very good. Okay. Next, we should move on to perhaps synthetic division, but sometimes, especially when you're doing the homework, you may encounter a polynomial not of degree 2, but a polynomial of degree 3, okay? So I'm gonna give you an example of that case, okay? So then we can move to synthetic division. All right, for example, this one looks good, the number 2, this guy. Let's do this one. What if they ask you to do this division, right? This one, I want to show you now. Yeah, so from scratch, right? Dividend, the one on the top, divisor, the one on the bottom. So what I do is division symbol here, I write my dividend inside the division symbol, right? And then I write my divisor outside, right? Outside. So here, 3x minus 2. Now start always by dividing the first term here by the first term here. But what is that? Well, negative 6x cubed divided by 3x is just negative 2x squared, right? Negative 2x squared. But this guy has a place here on top of the square term, right? Minus 2x squared, write it there. Then multiply this times the divisor, right? Divisor. And try to remember this when you do your homework. And this will give you what you have to write below here, right? This way. This will be negative 6x squared cubed, by the way, right? X squared times x cubed plus 4x squared, right? That you must write here, right? You must write here. Negative 6x cubed plus 4x squared. Professor, I got the same. You always should get the same, right? This should be the same as that. It's actually a sign that you're doing things right. Yes, now you gotta subtract, right? But I said to you guys, I help myself by distributing the sign separately, right? So I don't get confused. So this will be plus 6 cubed minus and plus minus 4x squared, right? Forget about this. I just do this 0 here, minus 5x squared minus 4x squared minus 9x squared, right? Okay. Minus 9x squared, great. Then bring down the next term is in this situation, in this case, 18x, because we're dealing with a cubic polynomial, right? And repeat the process, right? This guy divided by the first term. So minus 9x squared, 3x, right? This is negative 3, x into x squared, x, negative 3x. That negative 3x has a place here on top of the x term, right? Right there. And then multiply this guy times your divisor, right? Times your divisor. How? This way, 3x negative times 3x minus 2. Distribute, you get minus 9x squared. This will be plus 6x, right? And that is what you write here, minus 9x squared plus 6x. You're supposed to subtract this from the binomial on the top here, right? In order to, do this nicely, I distribute the sign here. This will become plus 9x squared. This will become minus 6x, right? This is 0 as usual, right? Not a surprise. This one, 12x. 12x. One more term here, the constant term, right? Which means that you have to bring it down, plus 11, right? And one more time you do this, right? And try to recall this, guys, for your homework. Okay, so now 12x divided by 3x. 12x divided by 3x, right? And eventually, guys, you will do this in your head probably, right? But I'm doing this step by step. 3 into 12 is 4, x into x 1, right? So 4. That 4 has a place. Write it on top of your constant term, right? 4. Now 4 times the divisor. 4 times the divisor is what? 4 times the divisor, 3x minus 2, will be simply 4 times 3x, 12x, 4 times negative 2 minus 8, right? Write it here. 12x, not a surprise, this will be always the same, these two guys, minus 8, right? Now you gotta subtract this. To subtract, remember guys, I help myself by distributing this negative sign. This becomes negative 12x, this becomes negative and negative positive 8, right? But now this will be 0, I forgot about this, right? 11 plus 8 is 19, right? 19. And then that's it, because there is nothing else to bring down, right? It ends here. Notice this division is not exact. It's showing me a remainder, right? So how I write my answer here? Answer. Well, first, always the quotient, right? Minus 2x squared minus 3x plus 4. Then I can write a big R and then the remainder, 19. This is one way, right? But there is another way, which is going to be used heavily in calculus too, is this. You write the quotient here, and then you add this proper fraction. Remainder on the top, on the numerator, on the denominator, the divisor, 3x minus 2. And turns out, if you look through, this is the choice C, right? They have used this form, as you can see, right? Yeah, not this form, but this. But sometimes they use this too. So this one is this, right? Follow, guys? Yeah, so in case they give you a cubic polynomial, they ask you to do long division, just follow this. I have attached even a video to help you out on your homework, okay? All right, this is long division, right? Long division. Now, mathematicians figure out that there is a case where we can simplify this process. Not always, right? But there is a case. When can we simplify this long division? Well, whenever the divisor has the form x plus something or x minus something. I will show you now. And that simplified version of long division, that limited simplified version of long division, is called synthetic division. I will explain it to you now. Yeah, I think I have one more example here. Yeah. Yeah, maybe we can, yeah, we can skip this one and then just go straight to synthetic division. Yeah, later probably we can go back to that. Yeah, synthetic division. This method, it can be used when the divisor is of the form x plus k or x minus k, where k is a real number, right? For example, x plus 2 or x minus 3. This type of divisors, for this type of divisor, we can use what is called synthetic division. This synthetic division is a very important method. It is optimal, means that there's no other way to do this faster, right? Optimal. The best method, right? To divide polynomials by this type of divisor, right? X plus something, x minus something. So let me show you how this method works, okay? So example here says divide these two guys, right? So first step, you're gonna draw a vertical line followed by a horizontal line this way, okay? And step 2, on this corner, you're gonna write the opposite of this guy. Opposite. What is the opposite of -3? Well, that is +3, right? +3. So that's what you write there. And over here, you're going to write just the coefficients, right? Pick up the coefficient. 5 here. -3 here. -30 here, right? This method works with just the numerical part of the polynomials, right? The coefficients. Does not work with the variable part. It's simpler. Now, next step, guys, you're gonna bring this down. Whatever this number is, the first coefficient, the leading coefficient comes as it is here, 5. Next, you're gonna multiply this 5 times this number that we got on the corner, right? So I'm gonna write here, multiply. When you multiply 5 times 3, that is a 15, right? You write it here below this second coefficient, right? And then you add these two, add these two with their respective signs. Negative 3 plus 15, negative 3 plus 15 is just 12, right? 12, positive 12, right? You can write positive 12. It's not going to hurt the sign. Positive 12. Good. Now, again, repeat. 12 now times 3. So multiply again. 12 times 3 is 36, right? Write that 36 below this guy, 36 here. Again, add. Adding negative 30 plus 36, that is just the number 6, right? Or positive 6. All right, and then you're done, because then what the method says is separate the last term from the rest, right? And this is going to be your remainder, right? Remainder. And this is going to be your quotient, okay? The quotient, professor, but I don't see any variables. Well, turns out this guy is going to be the constant term of your quotient, constant term, the last term of your quotient. And this guy will be the coefficient of your x term, coefficient of x term, right? Now, if you have more numbers here, the next will be the coefficient of the x squared term, right? And so on. The next, the coefficient of cube term, right? Depends, right? So basically, this is telling me that the answer should be what? The answer should be, this is the constant term of the quotient 12, positive, right? Plus, this is the coefficient of the x term. So you write 5x here. This is the quotient. And the remainder is this guy 6, right? 6. You follow that? 5x plus 12 quotient, remainder 6, right? Or on the using the other notation that is good for calculus 2, you will get here 5x plus 12 quotient plus this proper fraction, 6 on the top, the remainder on the top, and the divisor, this guy on the bottom, divisor, right? This guy here, down here. X minus 3. You follow that? Yeah, that's it. So it's a quick method, but again, it's limited because it's just for this form of the divisor, right? This type of divisors, x minus something or x plus something, right? If you see a number here in front of this x, then you cannot use this method, right? You have to use long division, right? When this leading coefficient is invisible 1 and there's some other number here, then you can use this method. Now, this method, guys, is very powerful. So I want you to learn this method because then we are going to use this method to evaluate polynomials and then find the zeros of polynomials efficiently, right? It's a very efficient method. Here is another example before I ask you to do some work on the worksheet. Suppose they ask you to divide these two polynomials. They don't tell you, right, divide using synthetic division, long division, but you quickly notice that the divisor is special. It's not just any divisor. Look at the divisor. It's the form x plus some real number, right, with invisible 1 up here. So this can be done using synthetic division, right? How? Well, again, you draw your vertical line, your horizontal line. Here on the corner, you write the opposite of this guy. Opposite of +2 is -2, right? -2. And up here, you write these coefficients, 3. Another coefficient here together with sign fly. And this one, -2, right? -2. There you go. Then it all starts by bringing this down as it is. It's a 3, right? So let's just write 3 here, 3. And then multiply 3 times -2. That is just, I'm going to still write multiply. I will stop doing that. So 3 times -2 is -6, which goes here, right? -6. Then add these two, right? Add these two. +5 plus -6 is -1, right? -1. Then again, -1 times this number in the corner, -2 is +2, right? +2, right down here, +2. And then you add these two numbers with their respective signs, -2 plus +2, 0, right? 0. Quickly, you separate the last number that you get there. That will be the remainder, right? The remainder. So, but this 0 as a remainder is telling me that the division was exact, right? Remainder 0, division was exact, right? Meaning I don't have to write the remainder, right, as part of my answer. My answer simply would be the quotient, right? The quotient answer will be just the quotient. But how I get the quotient out of these two numbers? I start here. -1 is going to be the constant term, right? The last term. And this guy is the coefficient of the x term, right? So 3x minus 1 should be the answer, the quotient, right? You follow, guys? Yeah, it's a very nice method. And you should learn it because we're going to use it a lot in the next section. Now, one note here. What if terms of the dividend are missing? You know, sometimes polynomials are not complete, right? So what if some terms are missing? Well, I will tell you what to do then. Let me give you this table and explain when a polynomial is not complete. Suppose you have this polynomial as your dividend, 3x squared minus 2x plus 7. Is this polynomial complete? Well, notice it has the constant term, it has the linear term, it has the square term. So yes, right, this is complete. So good. Now, question for you guys, is this polynomial 5x squared plus 8 complete? Anybody could write in the chat? Is it complete or not? And if it's not, what is missing? I see. Very good, very good. Second term is missing. Very good, Jack. Very good, Gingy. Can, right? Clearly is missing the x term, right? Okay. So whenever that is the case, if you are going to use synthetic division before you start, you should complete your polynomial this way. Look, you put a 0 there, 0x plus 8. Okay, guys? So 508 should go in here, right? 508. The 0 is important because if you ignore the 0, it's not going to work. Okay. Yeah. Now, question for you guys. Is this polynomial complete? 2x cubed minus 4x plus 9. Is it complete? Anyway, on the chat? And if it's not complete, what term is missing there? Students are sending. Very good, Khan. Very good. Second term, Jack, very good. Excellent. Second term is missing, right? The second term. Yeah, the quadratic term, right? Yeah, very good, right? So look, 2x cubed is there, right? But then it should follow the x squared term. It's not there, but you complete it by putting a 0 there, 0, okay? Minus 4x and then plus 9, right? Plus 9. So before you do the synthetic division, you have to put a 0 there because otherwise it's not going to work. Final answer, what is this polynomial? Is it complete or not? And if it's not complete, how many terms are missing? Very good, Can. Very good, Jack. Can is writing on the chat, missing x term and also missing x squared term, right? Second one term. Excellent, guys. Very good. I think you got it. Very good, right? So in this case, the situation is even worse. But no matter what is missing, what is important is that you complete it before you go ahead with the synthetic division, right? Because otherwise it's not going to work. Look, missing the x term, I added 0 times x squared plus 0 times x plus 3, right? And then on the horizontal row here, I have to write right here, -7, 0, 0, 3, and then here in the corner, the one that comes from the divisor, and then I proceed. Very good, guys. So if the polynomial is not complete, complete it, and then do the synthetic division. All right, so let's go over some examples then, right? Some examples so we can move on. Yeah, this one we will probably do later if we have time. So let's see, you're gonna try the following with synthetic division now. They start with this guy first, number 10, okay? Yeah, let's start perhaps with something, yeah, 10 is good. Yeah, for this, demystify is this, yeah, Suppose they ask you to do this via synthetic division. So try this, please, guys. Synthetic division is quick, don't worry. Look, I'm gonna start this out for you, right? Remember, the divisor determines this number is always the opposite, right? Opposite of +2 -2, right? +2 -2. Yeah, very good. And here we work with these coefficients, right? This guy, and this guy. So 4 here, +10 here, +9 here, +10 here. It's complete the polynomial, right? So go ahead and start by bringing this down and multiply, you know. Very good. I think students figure this out already. Very good. Jack, very good. Excellent. Yeah, excellent. You got it. Yeah, Jing, also good. Yeah, this method, this synthetic division, if you are headed to computer science, you should know this because it's a optimal method. Yeah, not all algorithms are optimal, but this one is, meaning there is no other way to do this process faster, right? Yeah, very good. Can also good, right? And it's going to help us to simplify our work, right? You will see next. All right, great. Excellent, guys. Excellent. So let's do it together. Look, 4 comes down as it is, 4, right? 4 times -2 is -8, right? And then you add these 2, right? Remember? +10 plus -8 is +2. Then you multiply again these 2, right? 2 times -2, that's -4. Add 9 plus -4 is +5. 5 times -2 -10, right? -10. 10 plus -10, 0, right? 0. So this means that this division is exact because the remainder is 0. So I just got to focus on the quotient, right? So answer the quotient, right? The quotient will be what? This will be the constant term. This, remember, is the coefficient of the x term. And this, since there is an extra number there, has to be the coefficient of the x squared term, right? So positive 5, and there you go. 4x squared plus 2x plus 5. 4x squared plus 2x plus 5 is this guy, right? Excellent. Very good, guys. Very good. Yeah, you see, it's much simpler than the long division, but the thing is that it's limited, unfortunately, right? It's just for this type of devices. But that is going to help us a lot in the next section. So I wanted to master this. So next question, let's try this one. It's a 4-degree polynomial, right? Yeah, try this. And then we will do one that is a little bit tricky. Yeah, so try to this. Yeah, as usual, I will start this for you. Vertical line, horizontal line. Here on the corner, you're going to write the opposite of this guy, opposite of -1, +1, right? 1. Then over here, there is an invisible 1 there, right? Invisible 1, so that invisible 1 here, -3, 1, invisible 1, 6, -8, right? Yeah, follow this. This polynomial is also complete, so I don't need to complete it, right? So just pick up the coefficients, write them out here, Here in the corner, the opposite. I'm still right here, opposite. And go ahead. Yeah, first step, bring this down, right? 1, and then multiply these 2. Yeah. And then try to remember this for your homework, guys. You're gonna be given polynomials degree 4, degree 3. It's a quick method. Yeah, and this one, I believe, has remainder because I see the form, right? They added a remainder there, so it's not gonna be exact. There's gonna be a remainder there, so figure it out, right? Yeah. I see some activity on the chat room. Yeah, very good, guys. Yeah, practice, guys. You don't have to be right all the time. What is important is that you practice. Jing, yeah, you made my day. Yeah, great, excellent, good work. Yeah, excellent, yeah. And this method again, guys, if your career is computer science, you should know this algorithm. It's gonna help you in different parts. All right, so let's do it together, right? 1 comes down as it is. Then 1 times 1, maybe I still should write the arrow for you to remember, right? 1 times 1 is 1, right? When you write here 1, then you add these 2, right? Add. -3 plus 1 is -2, right? -2. Then -2 times 1 again, right? Always you times, well, you are getting here by this number in the corner. -2 times 1, -2. Add 1 plus -2, -1. -1 times 1, -1, right? Add. This sum is 5. 5 times 1, 5. Add. -8 plus 5 is -3, right? -3. Excellent. Separate the last one from the rest. This is going to be your remainder. This time, we got a remainder, right? We got a remainder. So the remainder is going to be -3. We kind of write this backward, right? R. Then this 5 is the constant term of the quotient, right? -1. -1 is the coefficient of x. This is +5, right? -2 is the coefficient of x squared, right? X squared. And 1 is the coefficient of x cubed, right? I don't have to write the 1, right? So this is it. This is the quotient. This is the remainder. Written in the other form, this should be x cubed minus 2x squared minus x plus 5 plus this remainder, this a proper fraction. There's a -3 here, remainder. And on the bottom here, you write the quotient, this quotient as it is, x minus 1. This is what's going to go here, okay? X minus 1. X minus 1. Now, plus and minus is just minus, right? So mathematicians notice that and they wrote it like this. -3 x minus 1, right? Yeah, there you go. Therefore, the answer should be this guy, right? You follow, guys? Yeah. Great. Excellent. Okay, guys. So far, the polynomials were all complete. The dividends there were all complete. But what happens when this is not complete? Well, let me give you some example here somewhere. Here I saw it. It's number 13. Yes, here 13. This one. Can you try this? Yeah, hint. This guy is not complete. It's not complete, right? Clearly. The x term is missing, right? not complete. But that's not a problem because you can complete this polynomial as I showed you in the table, right? So use this. So think of your problem being this, right? And use your synthetic division, right, for 13. Let me see. Yeah, there's a question on the previous. Yeah, in the previous one, someone is saying, right? Isn't this -3? It is, right? Look at this. But what I did is this. Mathematicians, minimalistic people, right? They don't want to write plus and minus. Instead, they just want to write one sign. Plus multiplied by minus is the minus, right? You follow now? Is it clear now, the explanation? Plus and minus, minus. That's why this is minus.
Yes, but
you got it? Very good, Khan. Yeah, very good question, right? Yeah, and you may say, right, but why the obsession of turning everything into minimal representation? Well, notice if you transfer this to computer science, you have plus and minus 2 characters, right? 2 bits. Here, the representation requires just 1 bit, so it's a big deal. So you say, right? Yeah, very good. So,
yeah,
so
but
good.
I have the question like, why you put like the x minus 1 on the base?
Why x minus 1 on the base. Very good. This comes from the divisor. Whatever the divisor is, that's why I highlighted this in yellow. This has to be here. Because remember, when you do, remember at the very beginning, we said that if you divide 2 numbers, right? It comes from this. Maybe I can give you an example here. Let's say you divide 2 into the number 7. That is 3. 3 times 2, 6. What's the remainder? 1, right? Wow. 2 ways to represent this. Quotient 3, remainder 1, right? But there's another way, which is this. Quotient 3 plus 1 over the remainder here, 1 over the divisor 2. And this mathematicians simplify as this mixed number, right? You remember? Oh, yeah. 3.5, right? Comes from there. It's like what corresponds to this when you do it with numbers, right? Comes from there. This is like a mixed number, right? This looks like a mixed number, but in polynomial version, right? You follow now, Ken? Oh, yeah. Okay. Yeah. And this turns out, this representation is going to be very important when you take calculus 2 for the process of integration, So you will remember me when you take calculus 2, you say, oh, Professor Retamoso mentioned this form because you need this. You're going to need this in calculus 2. Yeah, very good. So good question. All right. Let's move on then. Yeah, let's go back and then let's finish this, right? Yeah, guys, finish this so we can take the break and move on. Yeah, finish this, please. Yeah, this will be on the corner. We have to write the opposite, right? So this -2. And here, invisible 1, then -1, invisible -1, then 0. It's very important that you put the 0, otherwise it's not going to work. And 5, right? 5. And then do the synthetic division. I see students already figure this out. Jin. Excellent. Yeah, very good. Savannah also. Very good, Savannah. Yeah, very good, guys, that you are picking this up. Yeah, very good. So 1 comes down as it is, right? Remember? Then 1 times this guy always, right? -2. Then you add these 2, right? That's going to be -3, -1 plus -2, -3. Then multiply this again, right? -3 times -2 happens to be +6. Add 6. 6 times -2, -12. -12 add -7, right? Good. Separate the last number from the rest. This is the remainder, right? This is our remainder. So this division was not exact. So what should be the answer then? Not exact. Answer should be the quotient and the remainder, right? I'm going to start kind of backwards. I'm going to write the remainder first with R. Then for the quotient, constant term 6. -3 is the coefficient of x, right? So this was positive. So -3 plus 6. And this 1 is the coefficient of x squared. I should write 1 here, but mathematicians don't write 1 when the leading coefficient is 1. This should be the quotient. This should be the remainder. Now, or you can write this in this form, x squared minus 3x plus 6 plus, remember, plus this proper fraction, minus 7, the remainder on the numerator. On the denominator, you just pick up whatever the denominator is. In this case, is x plus 2, right? Plus 2. Yeah, and then this, mathematicians write it like this, right? Since plus multiplied by minus, since this 2 is minus, it's like this, right? X plus 2, and that's it, guys. We're good. We're good to go here, yeah, that's it. By the way, here I think they have used this form, right? I think they're showing you what form, but they have used for some reason remainder this, quotient this, right? So you look through, and that is this guy, right? Yeah, very good. Quotient there and remainder, -7. Excellent. Yep. Okay, let's